Okay, so we're gonna continue on in module number 5, which is our machine vise project. Okay, this will be the only project that we do, but there's enough here. So it's putting together a number of different parts, creating the models, creating the detailed drawings, as well as the assembly and the assembly drawings. So what we call a full set of working drawings. Okay, so let's take a peek at the learning plan and kind of see where we're at. You're gonna notice that what I have for you here are the resources. And if you're, off campus, these are things that you're gonna want to print. And we're gonna be looking at most all of these things, between the last times that we were together and through the next or through tonight as well. But basically, I'm gonna go on the pictorial of the machinist vise. We are creating the assembly, and most specifically, all the models and the details for each one of the pieces to put this machine vise together. Okay, so using what you know about the ANSI standard, what you know about Creo, pulling this all together and creating a good set of working drawings so that this vise can be manufactured and assembled properly. Okay, so that is our goal. The main thing here is applying good modeling techniques as well as the ANSI standard when it comes to dimensioning. So that's what we've got on top here. These are basically drawings without the dimensions on. So if you wanted to sketch them out, like these are basically the views, if you would, so that you kind of know like how to lay them out, and then you can add any notes and such that you want to it. And at times we might be looking back at these as well. Additionally, these have the part number, the title block filled in with all of the material, which is also going to be on your pictorial drawing as well. Okay, so those are there for you to use as needed. As we look down here, it says you want to create the models and the corresponding detailed drawings. Each one of the models you need to save as the part number. So I'm kind of saying this again to you guys. Don't save it as base. Save it as 25010, okay? Because the title block is programmed, if you would, to use that file name for the part number in the actual title block. If you call it base, it's going to have base and where the part number is supposed to go. Okay. The base is going to be in the part name, which then you'll actually key in when you pull that border in. Okay. So we've done a demonstration or two on that, but just make sure that you're saving each model as their corresponding part number here. Okay. Apply tolerance as shown in the drawing guides below or in the drawing here. Something I want to point out is that there are some single place decimals and no place decimals on a couple of the dimensions on the machine vise. What I want you to do then is I want you to use the 2 place decimal in our title block, because that's the fewest number of decimal places and the least precise dimension. So convert anything that doesn't follow a 2 or a 3 place to just a 2 place decimal. Okay. That's that stuff. There's a drill guide there. Oh, here are the 3 guides that I'm giving you. All right. So you've got the vise screw. You'll notice that all of the dimensions and everything are on here to the ANSI standards. So what you want to do is basically duplicate what's here for the most part. Okay. You'll also notice that the next one that we have is the base and the sliding jaw. These are probably the 3 most complex parts that are in there models wise. So I wanted to give you those because there's quite a few dimensions, especially on the base and the sliding jaw. There's also a section or 2 in there that you want to be aware of. Okay. But the other ones, you get to choose how you're going to do those. All right. But make sure you're applying the ANSI standards. Submit all your details to assignments 9, 10, and 11, and make sure that you pay attention to which drawings go in which ones. All right. Create an assembly and a corresponding that we'll get to once we go over assemblies, and submit that to assignment number 12. But assignment number 12 is not, if you would, active at this time because we haven't gone over assemblies yet. So we're focusing right now on the details. So couple things that I want to talk about. So as I've been getting in some of the assignments, I want to be sure that we're all aware of a couple things. Number 1, I did have to add new borders out here. I apologize. I don't know why, but it must have been on my part. in the background, there was something like a bearing block or something. And if you pulled it in, it would say there was an error because there wasn't like this bearing, you know, in your working drawing or working directory. So what I had to do was, I think when I saved it, I mustn't have cleared my session and it was like hanging out in the background and it was part of it. So I had to redo the borders, which was fine. It was no big deal. But now what I need you to do is if you have the old borders in there from last week, which would have been Monday, you need to delete those completely out of your directory and reload these back in. Okay. They're called the same thing. So don't just reload over them because I don't want them to, you know, get messed up with the other ones. So make sure that you completely delete out all the other ones and pull in these and that they're all in the same working directory with the, with your other drawings. Okay. So that's number one. Okay. Number two, let's go to Creo. I'm going to open up Creo and I want to show you how to do the Acme thread. The Acme thread, we're not going to be drawing it, but you do need to show it in cosmetic thread form so that it shows it in its simplified form in the drawing itself so that you can dimension it. Okay. So, so I'm going to select my working directory here. And what I'm going to do is I'm going to open, let me think, I think that is the, I'll do it on the base, which is 25010. Okay. So here's my base right here. All right. And we're not going to model the threads, you know, so that they're the actual threads. You would do that, for instance, if we would 3D print this, okay? And we'd want to show and have the actual threads that would be actively in there. But for drawing purposes, we want to show them just in simplified format, all right? So, so how we're going to do that is we're going to draw as the model the actual hole that's in here just like this, okay? And then we are going to capture cosmetic threads by, once the hole is in there, you go up to engineering, okay? And it's down below, it's called cosmetic thread, okay? And we're going to go to standard thread. And then what we need to do is it's asking us to click on the item that we want to create as a cosmetic thread. And all I do is I grab the face here. I left click on that face, okay? And then it activates so that you can select the thread type. So you want to just do a UNC. We are not, they don't have Acme in here, which is fine, but we're going to do an UNC because what I want to happen is when we are in our drawing mode, we wanted to show those hidden lines for the root diameter, if you would, of the thread itself. Okay. And then we're going to pick, this corresponds to a 5/8 inch. We're going to go down to a 5/8 inch 11 thread. Now I know, again, this is not the accurate one, but we just wanted to show the simplified format of the threads in the drawing later on. Okay. Then what we want to do is we need to select the thread surface. Oh, I thought it, wait, there it is. And then we have to go to depth. We have to select where it's going to start from. So depth is the next little tab there. And you can start on either side. It's going to start on this side. And then all we have to do is we're going to go to depth. Now we could put in the depth there, or we can change this to reference 2. And I like that better because then it's going to be on the back side. So if that depth ever changes, it's going to go along with the whole depth of that. Okay. And then that's it. And then we can hit okay. And now we've got cosmetic threads in there. Now you'll see that there are 2 diameters like in there ish, but it doesn't look very different. Okay. And that's okay, because then on the drawing is where it's going to actually show up. Okay. Now it will pull in the designation for the 5/8 11. You'll just delete that. And then you're going to create a note and point to it. Okay. We're going to point to it. So, so to do that, why don't we pull this in? I'm going to file save so that I'm in here. And then I'm simply going to start new. I'm going to keep it in the background here, which is fine, or you don't have to have it open. I have to change mine because I already created a 25010. I'm going to go _2. You can click use drawing model file name, and it'll use that file name. And that's going to be what fills in the title block. Okay. So I encourage you to do that. I just can't because I already have one created. That's why. And the default model, so I can pull from that same model, use template, and then I'm going to browse to, I'm going to use my B-size 3-view WCTC, and I'm going to open it, and I'm going to hit OK. And I'm going to get something that looks like this. Okay. Now it's prompting me to fill in my material for this one. Remember, all caps, cast iron. Okay. My initials, and then this is called the base. Okay. All right. And now my title block filled in. Now, if for some reason, maybe you forgot you didn't have your caps lock on. All right. You can just simply double click here and you can get right into that text editing mode, and you can change this if you need to. So maybe some of you maybe have already experienced that, but just so you know, it's not like the end of the world. And again, down here, the part number is going to pull from your file number. Okay. So make sure that that's not base. I'll know right away if you didn't save it correctly, because base will be in here instead of the part number. Okay. Now you're going to notice the way this is filled in on parts that are complex. There's like a ton of dimensions that come in that are like, oh, wow, I really didn't want that many in there. And no lie, I probably wouldn't either. So what you can do is we can go through and we can actually just delete all of these dimensions. And then what I prefer to do is pull in by feature as opposed to by view. Okay. So I'll show you my approach to this. So again, there's like a ton here. So I'm simply going to grab a whole bunch of them. They'll highlight, and I'm just going to hit delete. Okay. And kind of do the same thing. Some of them I might keep, like this 0.25 radius. That's fine. But some of these, I just know that I won't use there anyway. And you can just go around and delete the ones that you don't want. Okay. And like I said, then I'm going to be pulling them back in by feature, because then there'll be fewer to deal with at once, and they're just easier to, oh, what? Yeah, I don't want to do that. Undo is my friend. Okay, I'm going to keep that one up there. Let me get rid of this one. This one. So this is, again, just to make it a little bit easier. The other thing that I turn off is going to be all of my axes and planes. All right. That cleans things up right away. All right. And you do that just by selecting this on and off. All right. And then you've got kind of a nice clean view here. Now, if you look at the non-dimensioned version of the base or the guide, you'll notice that we have the top view, the front view, the right side view, but also a section view over here. Okay. So to put that section view in, I wanted to kind of show you, and then you'll notice that we also have these lines. You might wonder what those are. Those are just snap lines so that you can know where you can put your dimensions. And the reason that they're there is because the standard says you don't want to be any closer than about a ½ inch away from the part. So it helps you to just gauge not to be any closer than a ½ inch away from the part. Some of these are overlapping just because there was multiple lines and there was just a lot of dimensions. So there's multiples in here. So if you go to annotate, you want to get rid of some of these, you can just select them and delete them. If you're like, yeah, they're kind of in the way. They don't have to be used, but they're a nice guide, especially when you're learning, that kind of a thing. But if you feel like they're in the way a little bit, especially there's like a whole bunch of them down here. Yeah, you can get rid of them. Okay, so let's create our section view, because I know that that's something that's not super intuitive. So I'm going to go over to layout, and I'm going to add a projected view. So I have to have a view there before I can assign it as an actual section view. So I'm going to do a projected view off of my front view. And I'm going to left click and then just drag and then click again over here. And there's just going to be, it's basically going to be a right side view. And then I'm going to click off of it, reselect it, and go to edit. And it'll be the drawing view edit type of a thing. Then I've got the view display. I'm going to go up to no hidden lines in a section view. All right. If you have any hidden lines in there, that's not to the standard. So make sure that you remove those. Okay. So do no hidden lines. And then also we're not going to do any tangent edges. So you can do an apply and you'll see what that looks like. Then what we're going to do is we're going to go to sections. Okay. To sections. And we're going to do a 2D cross section plus, now there's already an A in there because of the part. So I'm going to add a B. So I'm going to create new. And then it's going to ask me, I want it to be a planar single. I'm going to say done. Then up here, it's going to flash and it's going to say, what do you want to call it? I want to call it B. Okay. And then I need to select the plane. Okay. Now, when I created my feet up here, I added a plane to the middle of my base. And that plane is going to be in my design tree here. It's datum 1. Okay. So I don't know if you really saw it. It was datum 1 right here. It's a plane. It has the plane symbol. Okay. Datum 1. And so it selected it. And right now it's calling it, it's a full section. Okay. So everything is going good here. And all I have to do is say apply. All right. So I just want to be able to see this view and I'm going to say apply. And you'll notice that it's changed it to a section B. All right. And I'm going to hit OK. Now, as I look here, these lines are way too close together. All right. So I can simply left click on those. Of course not. I can left click on them and you'll notice that this menu comes up. Now you can go up here and adjust the scale if you want to, but visually, I'm going to do it again. Visually, there's this scale up button. If I just click that once, it's going to go a little further apart. I click it again, click it again. I just find this is easier visually to be like, oh, okay, that looks good. And then you don't have to try to figure out what is the scale that I should make that to. All right. So, so that's that. You also want to move this section B down, down, so that you're going to be fitting dimensions in, and you want that to be like the label of the actual view. So even though it's stuck it here, don't leave it there. You're going to move it down below away from where other dimensions are, but like highlighting and labeling that view. Now we do need to put arrows in here. All right. So on the layout menu, you're going to go to arrows and you're just going to click down in that right. Actually, I think you got to click left and then right. There you go. I'm sorry, right and then left. Click on that view and then back. If you do it right after you create the section view, it'll know it. But if you do it later, then you have to like say it's for this section view over here and then click on the view where you want the arrows to be. And then it's going to put it through. You can also select on these. Oopsie, I'm going to re-highlight on or get off of that. And I can select on this and I can move this down. See. And I can move my arrow and my B, my letter, however I need to. So so once you start adding dimensions, you may want to move that around a little bit. It's something that you can adjust. So that's the section view for that one. Let me just take a peek if there's anything else that I wanted to mention about the base. Oh, the Acme threads. So the Acme threads are here and they would be, now they're, for some reason, are they showing up on yours as you're looking, if anybody has it on the drawing? Yeah, mine didn't show up on mine either. I think they're just super small on here for some reason. They show up fine for the quarter 20, but I'm not sure why they're not showing up here. But if they don't, that's okay. Just make sure that you put the proper label on here. And the proper label is going to be, let me go underneath my camera here because it calls it out on the thing. So the proper label is going to be this right here, 0.625-8 Acme thread. Okay. And then you just point to it as a note. I see that there's a thing. Nope. Okay. I don't know what the nope was. I forget. All right. Oh, I think, are there any other questions? Is there anything else on here? So, so that's what I wanted to kind of point out. Oh, the other thing that I want to point out too is when you're modeling the base, you're going to notice that you have, you know, some dimensions that you have to add here that have tolerances on them. model them to the middle dimension. So for instance, on this one, it looks like if I do a 2, I would be plus 2 minus 2. So it would be 1.002 is what I would model it at. So that when I add the dimension and I do my tolerance, then I can just do a plus 2 thousandths minus 2 thousandths, and then it's even on both sides. Okay. It doesn't have to be even, but it's just kind of a nice way. That way it's the same in both directions. And then you show the limits. Any questions on how to specify a tolerance like this or how to get it to work like this in Creo? Let me tell you, if you put it in as a note or you fudge the dimensions somehow, I can tell that you didn't do it the proper way. So I'll remind you. Okay. So make sure that you use a tolerance. Any questions on that at all? Do you know, you don't know how to do that?
I know one last time.
Yep. Yep. Let's do it. Let's do it. Let me go back to Creo. Okay. So let's say I'm going to put the dimension between here. So I'm going to go to annotate, dimension. I'm going to grab this one and then I hit control, hit the other one, and then middle mouse button right here. Okay. So now it's here as number one, a 4-place decimal, and it's at 1.252. And if you look at the outside dimension underneath here, it's 1.254 to 1.250. So plus or minus 2 thousandths, right? So I'm going to go back to Creo. Okay. And I want to, first of all, put this to 3 decimal places. So I'm going to click on that dimension and it goes right into this, I forget what it's called. It's called the dimension ribbon. And I'm going to go over to the precision. I'm going to set it to 3. Then I'm going to go over to tolerance, just to the left here. And now on the right-hand side, I'm going to, this is going to be my plus 0.02. And then I'm going to do minus, and it does this. I don't know why it does this, minus 0.02. Okay. Then I have to go over to the left-hand side in this box. It's going to go out again, go back down, and I have to specify limits. I don't know why it does that. Does that do it to you guys too? Like in and out? Maybe it's just a little glitch on mine. I'm going to go to limits, and now I have my limits set there. Okay. Did that work, Spencer? Yeah. Right here. Yeah. So again, you click on the dimension. What was that? Oh, you get the plus minus. Oh, so down when you're in here for the tolerance, you're going to arrow down and you want to hit limits.
Okay.
Yep. And then now it should do what the top value is and the bottom value. Yep. Okay. Oops, I got 2 more chat. My tolerance sometimes is blue. Is that normal? Yeah, it'll do that on those diameter ones, and that is okay. Yep, I was going to ask the same thing. Yes, you're totally fine. Yeah, the diameter ones will do that when they're horizontal, right? Or sometimes when it's up down. Yeah, I don't know why it does that. I can't tell you. I'm not sure, but that's okay.
Do we have to create number 11?
No, no. You won't have to do the quarter 20. It's it's like in the toolbox that we can pull it out. Yep. The taper pin either. Yeah, just I think it's 10 pieces, right? 1 through 10. Yeah. All right. Okay. Trying to think if there's anything else on there that I can think of. Otherwise, we can always go back to it. I'm just gonna I'm gonna open the drawing that is there. Yeah. So as I'm looking, I'm just kind of, spacing is important. Oh, one thing I do want to remind you, I don't think it's on this one specifically, but if there's any references to drilling or reaming or tapping or any manufacturing process, do not include those notes in the callouts. I know they're on here, but that's not the standard ANSI standard call out for. So while all you want to do is you want to say it's a diameter of 0.25, okay? Or for instance, if we look down underneath here, if we see, it says a diameter of a number 25 drill. No. Just say a diameter of 0.14 or 1.149. Okay, that's all that you want to do. they might be able to drill it. They might not have to ream it. I mean, we don't want to dictate a manufacturing process. We're just telling them what the specification has to be, and however they can get it, they can get it. All right. So don't put drill or ream or tap on anything. Okay. Just give it its actual number that we're looking for. Yeah, like here, you might have to, and I did include the stare at drill chart. Here they're calling out a number 37 drill. Well, it doesn't tell you what the diameter is, right? So what would you do? You could Google it, right? But in your module, I do have a drill chart in there for you to reference. So if you go back into that learning plan, you'll notice that there's a stare at drill chart for you. So if you're wondering what diameter that corresponds to, do not put number 37 drill. Again, that's manufacturing process stuff. They can pick whatever it is. So you would go to the drill chart and you would find the number. Here's the drill size, the number 37. They're usually smaller when they're numbers. 37 is 0.104. Okay, that's the diameter. And that's the diameter you're going to draw to, and that's the diameter you're going to call out, not the number of the drill. Okay. Any questions about that? All right. That's a standard. Okay. Don't do that. They used to do it like this to kind of help manufacturing, but it was also at a time when you could predict what the actual process was going to be. We might not drill out the hole. It might be lasered, or I don't know what. All right. So we don't want to dictate that process for them. Okay.
Hey, Kelly, I have a quick question.
Yes, Lex. I think did you say you had a question?
Yeah, I did. Can you hear me okay?
Not great, but keep going.
Okay. When do you put through as next to a dimension, and when do you just let them assume?
Yeah, that's a good question. When do you put through and when do you not? You know, I always put through on if there's any question about if it's obvious or not. If you don't put it, it will be assumed, but I don't know, I kind of default to it sometimes if it's a little bit more complex part and it's not obvious if it's going through. If it's a real simple part where you can see, yeah, it's going through, then I don't add it. Does that make sense? I just add it when I feel like clarity is needed.
Okay.
Because sometimes it might be, you might, in that view, you might have a couple, hidden lines over the top or a feature or two in the way. And you just are like, you're focusing on that one. And I think it's a good idea to add it. So that's a kind of at your own discretion.
Okay.
Okay. All right. Let me get back to my list because there were some other things I wanted to make sure that we talked about. Oops. So I talked about the Acme thread and how to show that, using the WCTC borders, making sure we get the new ones in, tolerancing. We just looked at that, modeling to that middle number. Oh, I did want to let you know that the last time we were together, now on Tuesday, when we had the fire alarm and they closed down school for that evening, I'm going to let you know that I did record what we did. I had a couple students come on and we did a demonstration of the set screw. And we also did a demonstration of the draw plate. They weren't terribly, complex parts, but I'm not going to re-go over those this evening. Okay. So I did want to look at the handle rod. There was that. And we kind of looked at the base a little bit here. And then I would take any questions that you guys might have as you are working. So let's, I'm going to go underneath, and I have kind of, not really, I'm not going to say the keys or the drawing guides, but here we have the handle rod. Okay. So I'm going to encourage you that if you're not watching me right now, come back to me, because we're going to talk some dimensioning and things that you want to keep in mind as you do these drawings. So first and foremost, whenever we have a long or any type of a shaft, we do not, if we put a section through here, for instance, if you're like, I can't dimension to a hidden feature, I've got to put a section through here. If you put a full section through here, it's going to hatch the whole thing. That's illegal. That is against the standard. We don't do that on shafts, okay? We don't do the entire length. So what you're gonna wanna do is you're gonna wanna do something like this, where we call this a local type of a, or a breakout, but in the view, you would click on the view, and instead of doing a full section, you're gonna do a local section, okay? A local section. So to do that, I'm gonna show you how to do that in Creo, because that is something that's a little different. So let me go in here. This one I'm gonna open up. So 25,025. Okay, I don't see that I have a part there. So good. So I want to create the drawing for this. Okay. So I'm going to do file, new. I'm going to create the drawing, use the drawing file. Okay, we've got that. And I'm going to use an A size 2 view is fine. And then it should be good. All right. Now, of course, it doesn't come in the way I want it to, but that's okay. We're still going to demonstrate it. So material wise, I want cold roll steel. Parameter, KRR. And this is handle rod. There we go. Okay. So here again, notice that my part number came in as my file name. So make sure that you save it as the part number. And then I filled everything in here. Now, a couple of things. You'll notice that, you know, my dimensions are over here. They're coming in. So in this case, this isn't too bad, right? This isn't too bad. So here the dimensions come in on a simple part. It's kind of nice. You don't have to go in and redo it for each one of the views. You just might have to like move it to a different view, for instance. Okay. And then get rid of the dimensions that you don't need and all that kind of stuff. So so on the simple ones, the ones that aren't as many features, it'll pull these in and you can work with what's there and move those around. But let's add a little local view over here, even though in this case, the way it oriented, I wouldn't need it. So, so what I'm going to do is we're going to go to, I'm going to select this view. I'm going to edit that view. I'm going to go to sections, 2D. I'm going to add, and I'm just going to call it a planar or single. Done. We're going to call it A. Okay. And I'm going to select a plane, and I'm just going to select I think it would be the right plane that it would go through. I think it would be the right plane. All right. And you'll notice here that it says a full section. That means it would do a full section across that entire length. I don't want that. All right. Instead, I want a local section. So you're going to go to the arrow down there, and there's local. Okay. And now it wants you to select a point. So you're just going to select a point here. And then now it's telling you down here, we're going to make that spline around the area, just like we do for a detail drawing, to go just in that area that we want. Don't close it. And then just middle mouse button. And then we're going to hit, oh, well, let me see, create points of the spline for the pass through. Yep, I did that. Do I say apply? There we go. And then you can hit OK. Now, this is that same thing as before. If I click in there, I got to actually unselect the view first. Then I select in there. You can increase this, you know, increments at a time until you can do that. Now, in this case, I wouldn't have to do it the way that it oriented it. All right. And I didn't want to mess around with changing that orientation. But if it comes in like this, or if you want to use this type of a view, you would have to create a local section, or this can go for any other places that you find that it would be helpful. Josh. There was no dimension on there, right? That was me as the designer. That's the dimension I chose. So on here, you're going to notice they don't give you a dimension from the edge. But what it is you'll go to where this, the ball goes on to the end. And the part that's coming through here is going to be going, our part is going to go through the larger hole, and then a pin is going to pass through that hole. Does that make sense? And so when you look at the diameter, this is 3/4 diameter. So if you wanted to do 0.375 or something less, I just didn't want that handle sticking out of the end. So I picked 0.25. You could pick a dimension that you want, as long as you don't have it sticking out of the top or the bottom. Does that make sense? Yeah.
What was the
Which one? This one?
On the ball.
On the ball part? Yeah, number 37 drill. What size is that?
What is that? I don't.
Oh, so you'll notice that here is the ball. This rod right here is going to fit through here like this, okay? Then this diameter, this number 37 here, there's going to be a taper pin, and that's just a pin that is going to go all the way through here to keep the ball on the end. The taper pin is going to be a standard part. You don't have to draw that. Yep. The only thing that you're going to draw is going to be the sphere and the handle rod. Yep. And then there'll be a sphere on this end, a sphere on that end, and then they'll be pinned in two places. It's kind of like, it's hardware, so we're not going to draw it. Other questions? Good. Okay. Now, as you look at the Acme thread along here, all right, on our vise screw, this is going to be done the very same way that we showed it here. You're going to create a cosmetic thread on the outside to be as long as it needs to be here, okay? So, so that you'll create the outside diameter as it's solid. That's going to be the 5/8 inch, and then you're going to then do a cosmetic thread for that length. Okay. The other things I wanted to mention about the drawings. So as you create drawings, you'll notice that, you know, some of my guides, I want to make sure that you create an isometric view up in the corner for each one of these. All right. When you do that, most often you're going to create a view, and then it's going to want to put the scale is equal to. As I mentioned, I think it was the first time we were together, and we've gotten a lot of information about this, but delete this, okay? You don't need that scale up there. The only reason for the view is for clarity, all right? And having the scale column underneath it, yeah, that's accurate, it's fine, but get rid of it because it's just text on a drawing that's not really needed, all right? Also, make sure that you put it in no hidden or in solid with edges, okay? Those two are the best. If you do any of the other ones, then it kind of looks kind of weird and washed out, or you don't see the edges and it's kind of missing stuff. So in wireframes, it ends up being like too many lines to try to figure out. So, so one of those two is always the best up in the corner there. Make sure that your number of decimals has a tolerance. So there are a couple dimensions here. Where are they? Oh, here's a 1 inch dimension right here on that jaw plate. All right. There, if you put it in as a, you know, a 1 inch dimension, just one, or there's a 1.5 here, 1.5, one place decimal, our title block doesn't handle a tolerance for that. Okay. So what you need to do then is you need to put in 2 or 3 decimal places. Does that make sense to everybody? Okay. So put this up to a 2-place decimal. All right. If you see any other ones like that, you want to do that very same thing. Model to the middle and add the tolerances, add an isometric. Don't reference the manufacturing processes. Don't full section along the shafts. We did that. Oh, don't dimension on the part. I've caught this on a couple people's. Okay. So make sure that you're not putting dimensions like you see them here. Don't put them on the part. I know you see it here, but remember, we're applying the standards. And also don't dimension to any hidden features. Overall, what's come in so far, I think looks pretty darn good. So, so keep it up. And then, if you have any questions as you're working, let me know. Remember, when you're handing it in the first time, we're still practicing. We're still getting used to what are the standards, what are the rules, all that kind of stuff. And so I'll make notes. And if ever something that I put in doesn't make sense to you, let me know. Remember, you can always make the corrections, hand back in. This is a learning process. This is not, I don't expect perfection. Always put your best foot forward, but also know that, you know, I'm not expecting you to have everything down, you know, exactly perfectly. Okay. And use your references. Use chapter 11, I think it's chapter 11 and 12 in your tech drafting book. ask me. You guys did this stuff in tech drafting. You learned the rules back there, so you can use that stuff as well. So, so right now, are there any specific drawings that anybody's working on that you want some insights on? Remember, you have guides for the vice screw, for the base, and for the sliding jaw, which, like I said, I think are the most complex. Yes.
So. Understand when getting the. Like the unit threading, but. Like you did for the base, how it didn't have that packing thread, what
Yeah.
should we put something for it that doesn't have a thread type?
Well, again, it doesn't have the thread type, so pick the UNC. So it would be the 5A11, 5A16. I forget what it was. Pick that one. Yeah, pick the UNC color.
I know that there's reels.
It is going to be small. It is going to be small. That's okay. At least it's there. Otherwise, if you just point to it and it looks just like a solid section of the shaft, it doesn't even look like it's supposed to be threaded. Somebody will ask you about it. So just have the dotted lines in there. Yeah.
I just need to know the little depth on that job plate for that countersink bowl.
Oh, for the countersink hole. Yes, 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 yes. So for the jaw plate on the countersunk hole. So let me look. So I'm going to go to open. That is number 25030. All right. So these I put in as the hole wizard, which I'm like adverse to. So let's add it. So these were in as the hole wizard. So I did this as, I added a hole on this surface. I did a standard, and you had to pick your thread first. So, this was a 1/4 inch, right? So UNC, and then we needed to be the 1/4 20. Okay. And we want it to be a clearance hole for that. And we want it to be the countersink. Okay. Straight, standard, straight, countersink. And then the placement, we need to add the dimensions. So you have to take these broken arrows and put them to wherever it needs to be, 1 inch, and then over here, I don't know. I'm going to say 1.5. Okay, so it's in there. And then now you'll notice that it naturally creates it. Sometimes it'll go off the countersink and you'll have to just reselect it and then it'll go back on.
Oh, we don't like this shit.
You don't. As long as you have standard, straight, clearance, because that'll make the clearance hole then for you, countersink, and then you pick your fastener size over here. Yep. And then once you get it to the point, and like I said, sometimes when you're doing your dimensions, this will toggle off countersink, just toggle back on, and then you can hit your okay and it's in place. Now, the way it calls it out, you'll see it's going to call it out like this. You have to change that call out. Okay. Because we're not going to say an H drill, blah, blah, blah. Okay. Because we're not telling them how to do it. We're just going to say 1/4 20 UNC-2B. Oh, no. I'm so sorry. We're just going to do the countersink call out 82 degrees with a clearance hole of whatever that size was. Yeah. Because this is calling it out per the fastener, and that's not a fastener. We're calling out the countersink for it. Okay. And it's an 82 degree, which is the standard. And if I look, hold on, let me look at my drawing. Let me see how I called that one out. Open, just so that you can see it. Yeah. So diameter of 0.266 through, and then it's a diameter of 0.507 because that's the dimensioned diameter by 82 degrees. And then that would be the 0.507 is the outside diameter, the larger diameter. And then it's 82 degrees down. So then you don't have to worry about how deep that is. And then it'll automatically fit the head of a flathead screw. Okay. Other questions? As long as we're here, this is a good reminder again, the last time we were together, and I know I only did this once, so I want to do it again, to print this and to make your PDF, okay? Very slight difference than what I had anticipated. I talked to Tom and he's like, I don't know why this is, but it is. We have to go to the file, save as, and then we need to go to export, okay? And then once we export, we pick a PDF. And then you want to say export and okay. There we go. And then it'll make a PDF for you. Okay. And then you'll notice that all those extra lines are off of there. And yeah, and everything looks really nice and crisp and like an official drawing, which is nice. Okay. Oopsie. So it's just a slight difference rather than doing it out of the print or the plot, doing it out of the save instead. Was the export. Now I'm going to go underneath here. Are there any specific questions or drawings that you have? Oopsie, did I accidentally go out of here? Are there any specific part numbers that we want to look at drawing wise for any of these listed? It's your time. Say, I would like to see the drawing for, how would I dimension this? Or how would I approach that? At the moment. Your tolerancing is being weird? Okay. You can't put it in limits. Okay. So when you're in there, make sure, whoopsie, let me pick up one that's a dimension. Well, I'm going to see first. It should be through my templates. Okay. If you have my templates on, you should have that available. So if I click on one of these dimensions here, and I want to go to tolerance, okay? I'm first going to set my tolerance here. Okay. Did you do that already, Hans? What doesn't? Tolerance doesn't? It only has what?
It only drops down to the different tolerances. Like if you go to the left of the tolerance thing, it only uses that. It doesn't have that first box.
You don't have this?
No.
No, it's the other. So really? So you don't have this. All right. So then, I know in my, do you have the border in already? You have the border in? We did, but my template has that in there. My template has that in there. So if you go into prepare drawing properties, change, which one is it? It's the tolerance display, Hans. You're putting that in and hit enter. And just make sure it says yes. Yeah, yeah, okay. All right. And then close. And then, so if you go back up here, if you select a dimension, you go back up here, you don't get the ability to set this?
Yeah, it doesn't show that at the top, so I noticed in the ribbon. It's not the same tolerance drop down.
Right. So this looks different too?
Yeah, that is different.
All right, I'll have to come over and look at it. I don't know. Who else has a different tolerance? Spencer, you do? Anybody else? Now, are you on your own laptop or on a computer here? Josh, do you have the same thing? Does yours come up like this? All right. Well, it's no big deal. Yeah, that's kind of crucial. So if you go to limits, for instance, or plus or minus, yeah. I'll have to come over and look at it. Anybody else having any issues with the tolerancing? I'm gonna ask those who are offline. Are you guys not seeing the tolerance display over here like this? Or is it all normal to you guys? I can see it. Okay. All right. Then I'll check what's going on in the room here and hopefully we can resolve it. Any other questions? Otherwise, I'll let you guys work independently and I'll answer as they come up. I think mine's a little different, but I'm double checking. Okay, Emily said. And then I hope it goes without saying, I can see it as well. Okay, good, Corinne. Thank you. If I don't see the chat at the moment, I hope that those who are on, I've seen you guys answering each other's questions. So I love that. So please continue to do that. But I'm going to stop the recording right now so that there's not just a whole bunch of dead space, but I'll come back on if I need to demo something.